The human mind is always drawn towards the unknown. It is incredibly frightening, but from time and again, curiosity burns the will to explore beyond. Let me take you all on a journey into the abyss that this universe is, a place where darkness itself fears to exist. Traveling across the universe isn't just traveling through space, but through time as well. Before we get started, let's look into some facts. To find the edge, we should first know the dimensions of the universe. Our universe is expected to be 13.772 billion years old, quite old, isn't it? So how big is our universe really? Scientists today estimate it to be 28.5 gigaparsecs in width. To get a grasp of how huge that actually is, let us get to the basics of astronomical units. How large is a parsec? To understand how a parsec is defined, you should first know what an astronomical unit, is. One astronomical unit is essentially the average distance between the Sun and the Earth, approximately 150 million kilometers. So a parsec is defined as the longest length of a triangle whose shortest side is 1 astronomical unit and which subtends an angle of 1 arc-second at the opposite vertex. A simple calculation will get you, 1 parsec equals 3.26 light-years. Now, what is a light-year? It is the distance light travels in 1 year, which is about 9,460,000,000,000 kilometers. Here, we are taking about 28 gigaparsecs here, which is 93 billion light-years, i.e. 879 sextillion 780 quintillion kilometers. It is just unimaginably huge. Here is a little trivia: the length of DNA of all humans on Earth combined together, when stretched, will be about 0.119 billion light-years long, but that's a story for another day. If you look carefully, something is amiss about the distances here. It is well established that the speed of light is the absolute maximum speed possible. So, if the universe is 13.7 billion years old, how come the width of the universe be about 93 billion light-years? Technically, if an object created just after the Big Bang moved with the speed of light, it should by now have traveled a maximum of 13.7 billion light-years, nothing more, nothing less. From where did all the matter come from beyond this limit? Enter Hubble's law. It states that objects observed in deep space are found to be red-shifted. This holds the key to solve our conflict. Redshift, as the name implies, is the shifting of the wavelength of light to the red end of the spectrum, i.e. increase in the wavelength of light. But why does the wavelength expand? There can be two possible reasons: a gravitational field or expansion of space. When we say, the universe is expanding, it's not just that objects are moving away from one another, but the fabric of space itself is expanding. Here is where everything goes crazy: the expansion is accelerating. It is assumed that dark matter and dark energy have a strong influence on this behavior. So yeah, the extra distance due to the expansion of space needs to be taken into account when estimating of the width of the universe. So, the edge of the universe is clearly not at some 13 billion light-years from Earth. It is estimated to be much beyond that. Does the universe have an edge in the first place? Maybe. Maybe not. But, we can surely explore what it could be like if there was an edge. There is no way to accurately prove it or disprove it. Instead, what we can do is speculate. What is the farthest astronomical object humans can see? At about 2.53 million light-years from Earth, stands the Andromeda Galaxy. It's technically the farthest object visible to a naked human eye in the night sky. Almost the entire night sky you observe is just the stars and other entities of the Milky Way galaxy. Let us go much farther, to about 16 billion light-years from Earth. This marks the current cosmic event horizon of the universe. Are we there yet? Nope, not yet. This distance is the upper limit of light ever reaching us if it originated at that distance today. This implies, beyond 16 billion light-years, the expansion of space is faster than the speed of light itself. Obviously, light will never be able to reach us as it will have to travel through a relatively expanding space. This also signifies that any event that may have happened today, beyond the cosmic event horizon, will simply be not observable by us, no matter what. But we can actually see even further through telescopes. At about 32 billion light-years from Earth is where you'll find GNZ 11, the most distant galaxy ever observed. This distance is calculated by taking into account the expansion of space as well. What we essentially observe is the structure from 13.4 billion years in the past. Understand that light was emitted by these structures in the past when they were well within the cosmic event horizon, and hence we are able to see them. They are essentially the ghosts of their original self. And nope, the edge is nowhere near that. We need to go even beyond. Can we go even further? Let's see. One of the most prominent ways how we observe and explore the universe is by analyzing light or M waves. Clearly our observations are limited by the light that makes it to the Earth traveling through eons in space. The answer we seek might be hidden in the ancient light of the universe. The era of the origin of photons. To understand this, we must go back to about 377,000 years after Big Bang has occurred. It was called the epoch of recombination, marked by the origin of the very first neutral hydrogen atoms from the subatomic particles. So what's so special about it? When these atoms form, their electrons are in an excited state and hence immediately lose energy and go to a more stable state. What happens then to the lost energy? They are emitted as photons. This era is also marked by photon decoupling, where photons originated from matter and were freely able to move in space unbound by them. Today, 13 billion years later, we humans observe these primordial photons as the cosmic microwave background radiation. What's interesting is that this radiation is uniform and it is everywhere. There is no way one can determine from where it originated, unlike the radiations from a galaxy or other cosmic entities. Moving forward, at about 46 billion light-years from Earth, we reach what is called the surface of last scattering. That is what you will observe irrespective of the direction you look at. The surface of last scattering is like a uniform sphere of fog from which the first ever photons of cosmic microwave background radiation came from after recombination and photon decoupling. Contrary to the name, it is the origin of the very first scattering of light, but the last of what we can observe. Is this finally the edge of the universe? A yes and a no. Technically, this is the farthest point in space and also the farthest in time that we can observe. That essentially forms the edge of the observable universe. What lies even beyond that is what is known as the opaque universe. This marks the limit of what we can observe but not what we can imagine. Let us now go even beyond the edge of the observable universe. What can possibly even exist there? All this time, we have only explored what existed at a point in space in the distant past. A more unimaginable question would be, what could possibly be existing there at the present time? The edge of the observable universe also marks what is called the particle horizon, the maximum distance one can see into the past. Everything we have seen so far was from the perspective of keeping Earth at the center and scaling time to the past with distance. Imagine, in current time, your intergalactic twin lived on the particle horizon with respect to Earth. He would just observe cosmic microwave background radiation with respect to him, if he looks towards Earth. But wait, your intergalactic twin can actually see what is beyond the edge of our observable universe in present time, right? Does that mean the universe extends to another 46 billion light-years from his point of view? What if we have intergalactic triplets who can somehow instantaneously communicate with each other? If each one of them lived at the particle horizon of each one's observable universe, what will they actually see? What if we have two of the triplets placed at diametrically opposite positions on the particle horizon with their own particle horizons intersecting at Earth? Will the other end of their particle horizons also intersect at Earth? There is an inevitable question to ask at this point. Is the universe infinite? To answer it, we will have to refer to the work of our old man Einstein. One fact to state here is that our universe is surprisingly flat. Flat earthers, please don't ask, if the universe is flat, how come the Earth is round? From Einstein's theory of relativity, it can be estimated directly that a flat universe must be infinite. So, problem solved. And hence there is no edge or end to the universe. Not quite as you may have thought. What I mean by flat is not exactly what you are imagining right now. It is time to understand the difference between topology and geometry. The best and the most famous way to explain it would be through parallel lines. A flat geometry has parallel lines intact even when the topology or the way they are organized in space changes. As explained by the astrophysicist, Paul Sutter, take out your piece of paper with two parallel lines on it. Go ahead, dig it out of the trash. Wrap one end around to meet the other, making a cylinder. Carefully observe the parallel lines, they remain parallel, don't they? That's because cylinders are flat. The universe has a flat geometry but an unknown and unpredictable topology. The existence of uniform cosmic microwave background radiation itself signifies this very fact. Even so, we cannot be sure with the indefiniteness of the universe due to various inconsistencies in measurements. A flat universe comes with its own problems contradicting the original Big Bang theory. If the universe is flat now, it should have been flat from the beginning, but that doesn't seem to be the case. This can be resolved by using the concept of inflation, which again comes with its own speculations. We have so many other theories like the multiverse and the string theory to explain the magical realm in which we exist. I wouldn't be surprised if everything we are in is nothing but a simulation by an alien entity, or worse, a science project of a random alien kid who got a C for it. At the end of the day, we can't be sure yet if the universe is finite or infinite, and if there even exists an end to it. Perhaps, this certainty and uncertainty is what makes astronomy truly astonishing. One thing's for sure, whatever lies beyond the edge of the universe is for the Almighty to know and for humanity to never find out, but mankind will continue to explore this deep abyss of nothingness, hoping that someday the truth behind everything will be found.